In this video, we're going to talk about prime and composite numbers. There are a couple of ways that we can actually look at trying to determine whether or not a number is prime or composite. Okay, let's take the number 8, for example. Alright, if I count out 8 tiles, okay, then I can make a rectangle out of those 8 tiles. Alright? Now, I can make a rectangle that looks like this. Okay? In other words, a rectangle that is 2 on this side by 4 on this side. So, we could make a rectangle that's 2 by 4. And we could also make a rectangle that is 1 on this side by 8 on this side. So we can make these two area models with a total of 8 tiles. So that if I have more than one rectangle, then the number is composite. So the number 8 is composite because there are two different ways to make the rectangle. Alright, let's look at the number 5. Alright, if I take the number 5 and put 5 tiles out here, I can obviously make a rectangle that's 5 by 1 or 1 by 5. 1 this way, 5 across here. Okay, now if I try to make a rectangle that's in 2 rows like I did with the other, I don't have a rectangle because I've got this piece in the corner that's sliced out. Okay, so the only way that I can make a rectangle out of 5 tiles is as a 1 by 5 rectangle. In other words, there's one rectangle. So if there's one area model or one rectangle, then I have a prime number. If there's more than one, I have a composite number. Okay, now beyond the area model, we can also look at finding prime and composite by looking at prime factorization. Okay? The fundamental theorem of arithmetic says that every number can be written as a product of unique prime factors. So, in other words, if I write one number as 2 to the second times 3 to the second, that represents only one number. Those prime factors wouldn't be prime factors of more than one number. Okay? And that's the fundamental theorem of arithmetic. So what I want to do is I want to do prime factorization of some numbers. Okay, there are a lot of different ways that I can do prime factorization, but one of the easiest ways to do prime factorization is simply to create a factor tree. Excuse me. For example, let's look at the number 18. There are a lot of different ways that I can factor 18. So what I want to do is I want to factor 18 and make a tree with 2 factors. So other than 1 and 18, I don't want to start out with the one set of factors that have 1. Alright, so one way to get 18 is by multiplying 2 times 9. Now, in order to identify the prime factors that I need, I've got to have some way to show prime factors as I get them. So, prime factors are actually numbers that only have 2 factors. The number 1 and the number itself. So we're talking about numbers like 2, 3, 5, 7, 11, 13, and so forth. Now see, there's no pattern here. Okay? Now, I look at composite numbers, so we're talking about numbers that have the 2 more than one way that we can do a rectangle, or more than one set of factors. So we're talking about numbers like 4, all the numbers in between these. Okay, 5 is represented, the number 6, 7 is prime, 8, 9, and 10 are all composite, 11 is prime, 12 is composite, 13 is prime, 14 is composite, and so forth. Now, 1 is neither prime nor composite, okay, because 1 has only one factor, okay? So it doesn't fit the bill of being a prime number as having 2 factors. 1 times 1 is the only way to get 1 here with an integer, okay? Now, with each of these, I can find a way other than 1 times 4, and that would be 2 times 2. Here I could find another way other than 10 times 1, so that would be 2 times 5. Now, when I look at a number like 12, I can find several factors, not just 1 times 12, 6 times 2, 3 times 4. So there are multiple ways other than 1 and 12 to get the number 12. So what I want to do is I want to break this number down into factors that are prime. So 2 is in my prime number list, so I'm going to circle it. Some people underline. Whatever you do, you just need a method to identify numbers as they become prime. Now, I can factor 9 again. 2 numbers that give me 9 are 3 times 3. Now, these are prime. So the prime factorization of 18 is these numbers that I've circled multiplied together. So 2 times 3 times 3. Now, when we talk prime factorization, we always want to write those ultimately as a prime number as the base with an exponential power. Okay? So to get 2, that's 2 to the first power, but I don't need to put the little 1 up there as an exponent. 2 is just fine. Okay, now I can also put the cross mark, or I can put the dot. So I'm going to go ahead and change, and I'm going to write, I call it the big girl math sign, okay, which is the dot in the middle, or parentheses, either one you want. Now, I have 2, count them, 1, 2, 3s. So I have 3 multiplied together 2 times. The number of 3s indicates the exponent. So the prime factorization, and remember that's unique because of the fundamental theorem of arithmetic, the unique prime factorization of 18 is 2 times 3 to the second. Okay? Let's look at a number like 1040. Okay, that's a really big number, isn't it? And at first glance, you might look at it and say, okay, I'm going to spend my whole day trying to figure out what numbers are going to go into that. Okay, no, I don't have to do that. I just pick something that I know. Now, from homework 3, we know about divisibility. And we know that anything that ends in a 0 is going to be divisible by 10. Okay? So that I know this will be 104 times 10. Now, neither of these numbers is prime, so we don't circle. This ends in a 4. That's an even number, so we know it divides by 2. So we don't have to pick large numbers. We can look at something and decide if it's even, it will always divide by 2. So we can keep breaking it down by 2. Our tree's going to be longer. Doesn't matter, we're going to end up with the same thing. Alright, so this would be 52 times 2. Okay? Now, 2 is a prime number, so I'm going to circle it. Now, 52. What are the things that multiply and get 52? Okay? We don't need to try very hard because we can look at this and say, ooh, it ends in 2, so it's divisible by 2. So 2 into 52 is 26. So 26 times 2, and 2 is prime. Now, we know that this also divides by 2, and that's 13 times 2. Now, both of these are prime. Alright, now we took care of the 104. Now we've got to take care of 10. Okay, so the prime factors of 10, okay, we've got 5 times 2, and that's it, because those are both prime. Now, we have to be careful here because we've got multiple 2's. So instead of writing it out longhand like this, all I'm going to do is write down the numbers, the prime factors from smallest to largest. So I have 2's, I have 5's, and I have 13's. Now let's count up how many of those bases we have. I have 1 13, I've got 1 5. Now I need to worry about 2's. So I have 1, 2, 3, 4 2's. So the unique prime factorization for 1040 is 2 to the 4th power times 5 times 13. Now, granted, you could use larger numbers than we used. We wouldn't have to divide by 2. We could have divided by 4. We could have divided by 8. Okay? We could have looked at this number and said it ends in a 4, so we know that it's divisible by 4. All right, but we're good to go with this now. Now, I want to go back. I want to back up just a minute real quick here. And I want to show you, because I didn't do this, I want to show you that prime factorization is unique. So let's just look at 18, because that's a quick and easy number here. We started out with this prime factorization tree as 2 times 9. There are other factors that give me 18, such as 6 times 3. So let's try that and see what happens. 3 is prime, and then 6 is 2 times 3, and both of those are prime. Now, when I write down my 2, write down my 3, I have 1, 2, 2 3's. No matter how I factor it, I still get the exact same prime factorization. So it is unique. Okay? Now, let's kind of review real quickly again. If it makes more than one rectangle, like 4 makes more than one rectangle, it has the 1 by 4, but it also has a 2 by 2. So 4 is not prime, it's composite. If I have a number like 3, okay, there's only one way to make a rectangle, because when I try to double it here, I've got a piece left out. So the only way that I can make that rectangle is 1 by 3. So there's one rectangle, so this number is prime.